Hi from Miss Brown. Today it's water and its properties. Now you have an organizer to help you with note taking today, and my virtual learners, you can print yours off. I link that in your lesson plan as well. Alright, so here's your first ones. 70% of you is water, of your human body, and your cells are filled with water, and cellular events take place in water. Cells are surrounded by water, and nutrients move in and out of cells dissolved in water. And of course, many organisms on Earth live in water habitats. So you see why water is so important to us. Keep in mind, you can stop this screencast to fill in your notes and then start it again. Now, water's heat properties. The boiling point of water is 100 degrees Celsius, and the freezing point is 0 degrees Celsius. Remember, we use Celsius in science. The specific heat of water is the amount of heat required to raise the temperature of water by 1 degree. And water heats slowly and retains its heat longer than other substances. Now, we release heat through the evaporation of water like sweat, and as gross as it seems, sweat does cool us off. And the water in your body helps maintain a constant temperature. And that's an example of homeostasis. Well, first of all, if you get dehydrated out in the heat, that will affect your body temperature and can lead to some serious problems with overheating. And homeostasis is that steady state we talked about before that all living things have with certain levels in their bodies. Okay, water's attraction properties. When they're attracted to other water molecules, that's called cohesion. That's how we have drops of water. And what causes that is these things called hydrogen bonds. They're weak bonds that hold molecules together at the surface. And this is often what causes this wonderful thing called a belly buster. If you've ever done that or ever landed in water and hurt yourself, that's the surface tension of water. An example of that is the bugs that can walk on water. Not all bugs, but there are certain things called water striders. You've probably seen those at the lake or at a pond. If you've ever hung out there in the summertime or springtime, you'll see those walking around on water, and they're just using that water tension. Now, water molecules will stick to other substances besides water by the force of adhesion. And that's what allows things to get wet. Water sticks to you. And also when water sticks to things, it's what causes capillary action. And that's how water rises from the roots of a tree all the way to the top. It doesn't have a heart pumping the fluids like we do. It actually sticks to the sides of those vessels as it moves up into the tree in the xylem and the phloem. And you've seen this before when they stick your finger at the doctor and they use that little plastic tube and the blood just goes right up it by itself. That's capillary action. It's sticking to the sides of that tube. Now we call water the universal solvent. It doesn't dissolve everything, but it dissolves many things. And this is kind of a review. Substances that dissolve in water make a solution. And those solutions that have water as a solvent are aqueous or aqueous solutions. And this works because water is a polar molecule. And you can see here it's polar because one end is slightly negative and these other ends are slightly positive because the electrons are not shared equally. So it's polar. It pulls to one side more than the other. And this negative part of water will stick to the positive part of another molecule of water. That's what makes them stick together just a little. So when you bust through it with a belly buster, you're well aware of what happens. So in the margin, I want you to make a drawing of this, please, and show the positive end and negative end. Now, because of this property, water best dissolves other polar compounds and ionic molecules. And ionic molecules release ions when they're dissolved in water. And water will not dissolve non-polar molecules like oil. That's why you have to shake up, homemade salad dressing has to be shook up because it'll separate. Now, these substances that easily dissolve in water are said to be hydrophilic. Hydro meaning water and philic meaning to love. And substances that do not dissolve readily in water are called hydrophobic. Again, hydro meaning water and phobic meaning fear of. Now, when water freezes, it becomes most dense at 4 degrees right before it freezes, right above the freezing point. And ice floats on water because when water freezes, it spreads out. So you've got the same mass of substance, but it takes up more space. So it's a little less dense. So it just slightly floats on water. And that's what causes overturn in the fall and the spring. Sometimes our water tastes funny because it turns over in the lake. And we get that bottom part up on top and it has a little different flavor for us. All right, ionization properties. So water can ionize. Compounds that add hydronium ions to water, which is H+, are called acids. And compounds that add H negative, I should say OH negative, that is a mistake on your paper, to water, they're called bases. And there'll be another video about this a little later. Okay, concentrations of acids and bases are measured on what we call a pH scale. And the pH scale will range from 0 to 14. Pure water, sorry, I went backwards, I'm sorry. Pure water has a pH of 7. Acids have a pH less than 7 or below 7. And bases have a pH greater or above 7. And the smaller the number, the stronger the acid, and the larger the number, the stronger the base. And numbers on the pH scale represent a 10-fold change in pH, and we'll be talking about that a little bit more in the next video. Thank you.